Today we are going to discuss about how to create transitive closure of a graph using Warshals algorithm. Transitive closure is basically a Boolean matrix, that is matrix with zeros and ones, in which the existence of directed paths of arbitrary lengths between vertices is mentioned. A graph is given and its transitive closure is also specified as a Boolean matrix. The transitive closure can be generated with a depth first search or with breadth first search. This traversing can be done from any vertex. While computing transitive closure, we have to start with some vertex and have to find all edges which are reachable to every other vertex. The reachable edges for all vertices has to be obtained. Let me explain what is Warshall's algorithm to find transitive closure of a graph. While computing transitive closure, we have to traverse the graph several times. To avoid this repeated traversing through graph, a new algorithm is discovered by S. Warshal, which is called Warshall's algorithm. Warshall's algorithm constructs transitive closure of a given digraph with n vertices through a series of n by n Boolean matrices. The computations in Warshall's algorithm are given by the following sequence R0, Rk minus 1, Rk up to Rn, where these are said to be ranking matrices. Key idea in Warshall's algorithm is building of Boolean matrices. They are ranking matrices. The procedure to be followed algorithm. First step. Start with computation of R0, ranking matrix 0. In R0, any path with intermediate vertices is not allowed. That means only directed edges towards the vertices are considered. In other words, the path length of one edge is allowed in R0. Thus, R0 is adjacency matrix for the digraph, which is nothing but R0 is nothing but adjacency matrix. If there is an edge, we represent with 1. If there is no edge, direct edge, we represent with 0. Either 1 or 0. Then construct step 2. Construct R1 ranking matrix 1 in which first vertex is used as intermediate vertex and the path length of two edges is allowed. Note that R1 is built using R0 which is already computed. We have already computed R0 where it is adjacency matrix. With help of R0 ranking matrix 0, that is there are no intermediate vertices. Here we are going to find R1, that is where the first vertex is taken as intermediate vertex. Go on building Rk by adding one intermediate vertex each time and with more path length. Each Rk has to be built from Rk minus 1. Rk can be built through Rk minus 1. The last matrix in this series is Rn. If there are n number of vertices, we have to find Rn ranking matrix n. In this ranking matrix n, where there are n number of vertices, are used as intermediate vertices, and Rn, which is obtained, is nothing but the transitive closure. Rn ranking matrix n is transitive closure. We are going to find so many ranking matrices. That is, initially ranking matrix 0 is it just an adjacency matrix. Then we assume that one vertex as intermediate vertex here, next two vertices as intermediate, next three vertices as intermediate, etc., etc. n vertices as intermediate vertices. All these are said to be ranking 0, ranking 1, ranking matrix 2, ranking matrix n. Initially, first one is there are no intermediate vertices. Then R1 is with one intermediate vertex, with two intermediate vertices, etc. up to with n intermediate vertices. To make it clear, let me take an example and derive the ranking matrix 0 to Rn. Let me explain using an example. Find transitive closure for the following graph using Warshals algorithm. Initially, the graph given is A, B, C, D. It is a digraph. Some edges are there A, B, B, C, C, D, D, E, and A, C. So there are five edges, directed edges, and let me find out the adjacency matrix. Adjacency matrix. If there is a edge, if there is an edge between two vertices, represent it as 1. If there is no edge between two vertices, represent it as 0. A to A 0, A to B, yes, there is an edge 1. A to C, there is an edge. A to D, there is no edge, there is no path from A to D, so A to D is 0. Then B, B to A, there is no edge, 0. B to B, no edge. B to C, there is an edge. B to D, there is no direct edge, 0. Then C, C to A, C to A, 0, no edge. C to B, no edge. C to D, C to C, no edge. C to D, edge, 1. D, D to A, there is an edge. D to B, there is no edge, 0. D to C, there is no edge. D to D, there is no edge. So this is said to be R0, direct ranking, right? Adjacency matrix, where there is an edge, we represent it as a 1. Where there is no edge, we represent it as 0. So R0, 0 means there are no intermediate vertices, no intermediate nodes. R0 ranking matrix with 0 intermediate nodes. Now we are going to find R1, R1 ranking matrix with one intermediate vertex. Assume that A is the intermediate vertex. A is intermediate vertex. R1 ranking matrix 1 with one intermediate nodes, where we use A as intermediate node. So here we assume that if there is an intermediate node A, the path length contains two edges. Path length may contain two edges if A is intermediate. A to A 0, A to B there is an edge. A to C there is no, yes, there is an edge. A to D with only two, no, no, there is nothing. A to D 0. Then B to C, B to A, no, no, no vertex, no edge. B to B, no edge. B to C, there is an edge. B to D, B to D. C is not a intermediate vertex. So B to D 0. Then C, C to A, no edge. C to B, no edge. C to C, no edge. C to D, there is an edge. Then D, D to A, there is an edge. D to B, intermediate is A. So we can allow A as intermediate node. So D, A, B, there is an edge. Then we can use D, A, C, there is an edge. D to D, no edge. So this is the ranking matrix where A as intermediate node, A as intermediate node. A as intermediate node. Now we use another vertex also as intermediate node, B. Now A, B as intermediate nodes. two vertices as intermediate nodes. Intermediate. So we are going to identify R2 ranking matrix 2. R2 ranking matrix with two intermediate nodes. So between, say, suppose B to C, B to C, D, A, B, C, D, A, C, you can assign like this. Then C, D, A, C, D allowed, but C, D, A not allowed. See here, for example, A to A 0, A to B, yes, there is an edge, A to C, there is an edge, A to D, there is no edge, right? A to D, you can have B as intermediate node, then C, then no intermediate node, right? So A to D 0, then B, B to A, no vertex, B to C, there is a vertex, there is an edge, B to D direct, there is no intermediate node, so B to D 0, then C, C to D, C to A, no, C to B, no, C to C, no, C to D, yes, then D. From D, you can have two intermediate vertices, T to A, there is an edge, D to B, yes, A can be intermediate. So then next one is B, there is an edge. Then D to C, A, B, D, or D, A, C, or D, A, B, C, you can have it. Then D to D 0, there is no vertex. So here whatever the matrix generated in here is ranking matrix with two intermediate nodes, with A, B as intermediate nodes. Now we find out R3 with three intermediate nodes, A, B, C. A, B, C as intermediate nodes. When A, B, C as intermediate nodes, D, D to D, D to D is also 1. D to D is also 1, the only change. So D, A, B, C, next one is D. Then all remaining are same as usual. D, A to D, A to D also one more is there. A to D, A, B, C, D. A to A, 0, A to B, edge, A to C, because this can be acted as intermediate node. A to C, there is a path. A to D, A, B, C, both are all the three can be acted as intermediate vertices. So there is a path from A to D. A to D is also 1. So this is the matrix mentioned as ranking 3. So rank 3 means with 3 vertices as intermediate vertices. Initially there are no intermediate vertices R0, A as intermediate vertex, then AB as intermediate vertex R2, ABC as intermediate vertex R3. Now we are going to find R4, A, B, C, D, all 4 intermediate vertex. Intermediate nodes. So we are going to find ranking matrix 4. If ranking matrix 4, so A, if you start from A, you can move to any node A, B, A, C, A, D, then A to A. If it is B, B to A, B to A, B, C, D, A. There is a possibility. Then B, C, B, D, B, C, D. Then C, C, A, C, A. How? C, D, A. Then C, B, C, D, A, B. Then C, C, D, A, C. Then C, D, C, D. Then D. From D, you can move to A. D, A, there is a path. D, A, B, there is a path. D, A, C, B, C, there is a path. D, A, B, C, D, there is a path. So, there is a path from any node to any other node if you use all four vertices as intermediate vertices. So R4 is your transitive closure. There is a path from any node to any other node in this particular graph. So note that every vertex is reachable from every vertex. So R4 ranking matrix with 4 intermediate nodes is the transitive closure. The central idea of this algorithm is what we can compute all the elements of each matrix Rk from the previous matrix Rk minus 1. Initially we have evaluated R0. There are no intermediate vertices ranking matrix 0. Then we use R1 ranking matrix 1. Then we find R2 ranking matrix 2. Then R3. Then R4 where there are only 4 matrices. So 4 vertices. In this particular graph there are 4 vertices. Suppose if there are n vertices, you may extend this up to ranking matrix of n where Rn will be your transitive closure. In here R4 there are 4 vertices, so R4 is your transitive closure. In here it was derived as any vertex or any node can be reachable by any other node. So there is a path from any node to any node. So this is nothing but the transitive closure of the graph using Warshall's algorithm. Thank you.